Welcome back, everybody. Today we're going to continue talking about the law of sines, but we're going to talk about one very specific case. In the prior video, we talked in general about the basics of the law of sines. If you're given information about a triangle, how to get the other information, and I think we did one or two application problems. Today we're going to talk about something called the ambiguous case. And the ambiguous case comes in if you have two sides and the angle opposite one of them. So for example, if I have B and A and angle A, right? We could have multiple triangles. Could have a triangle like that. Right? We could have one with an acute angle, right? We could have one with an obtuse angle. All right. Or we could potentially have not a triangle at all. I'll make that a little bit better. What's going on? All right. So with these three possibilities, we need to start out by determining which one we have. Then if we do have a triangle, determining, answering the question. If we don't have a triangle, proving that we don't. So let's just jump right into an example. All right. So let's start with angle A equals 120 degrees. Side A equals 22 centimeters. And side B equals 15 centimeters. All right. So there's my 120 degrees. There's my 15. And there's my 22. All right. So the first thing we can determine is that we have a triangle. All right. Since A is greater than B, meaning sides, all right, a triangle is possible. All right, so now we can determine other things. So the first thing I want to know is, right, if this is side B, then this is angle B. So we want to try to get angle B. Now again, law of sines, probably going to have to use a calculator if you want to get an exact figure. If your class does not use calculators, I'll show you basically where you end. So we have 22 over the sine of 120 degrees equals 15 over the sine of B. All right, and now we cross multiply and divide. We cross multiply and divide. So I get the sine of B equals 15 sine 120 degrees over 22. All right, so let's see. If we had the sine of 120 degrees, that would be up here. That would be 60 and 30, so that's 1/2, and that's radical 3 over 2. So you're going to substitute radical 3 over 2 in for sine of 120. Probably just easier if you use a calculator. So why don't you do that? Why don't you use a calculator to finish up to give me angle B? To get angle B would equal the arc sine of 15 sine 120 degrees If your calculator has modes, you probably want to make sure you are in degree mode over 22. And I'll give you the answer on the back end. All right, hopefully you paused the video for a moment to get your answer. I got 36.2 degrees. All right, so the next thing we want to do is find side C. All right, now we have 120. We also have 36.2 plus angle C is going to equal 180 degrees. All right, so why don't you do a little bit of algebra, find out what angle C is, right? This is angle C. Make it a bigger C. So actually, you know what I'll do? I'll do this. I'll say plus angle C equals 180 degrees, and we'll talk about the answer on the back end. All right, so I got 156.2 plus angle C equals 180. And I got angle C equaling 23.8. Yep, looks good. All right, so now we're going to find side C. So to find side C, we're going to do 22 over sine of 120 degrees equals side C over the sine of 23.8 degrees. We're going to cross multiply and divide. So I get C equals 22 sine of 23.8 over the sine of 120. Now, sine of 120, we know without a calculator, but sine of 23.8, we certainly do not know. So if your class is asked not to use a calculator, this is where you would leave it. If you're allowed to use a calculator, you can give me an estimate of this side. And usually I would go to the tenths or the hundredths. Let's go to the tenths for today. Why don't you take a moment and get your answer, and I'll give you the answer on the back end. All right, hopefully you paused the video to get your answer. I got 10.3 centimeters. So we got our final answer would be angle B equals 36.2. Angle C equals 23.8. And side C equals 10.3 centimeters. All right. So situation 2 comes into play with a different example. So let's say angle A equals 40 degrees. Side A equals 12 centimeters. And side B equals 15 centimeters. All right, so since angle A is acute, we potentially have multiple possibilities. All right, so the first thing I want to do is I want to find the height of, I'm going to draw my triangle just so I can see what I'm looking at. So I got 40, I got 12, I got 15, and this doesn't necessarily reach the bottom, but it could reach the bottom. We just don't know yet. But really, well, that's actually a bad representation. Here is your height of your triangle, and your 12 kind of goes out that way, and we're not 100% sure if it reaches down or not. So the first thing I want to do is I want to find the height of my triangle. So I can use SOHCAHTOA. So the sine of 40 is going to equal h over 15. So then I would do h equals 15 sine 40. And again, if you're not allowed to use a calculator, here's where you have to stop. But if you are, or potentially in the directions, you could be given the decimal of what sine 40 is. All right, so that is a possibility as well. So for example, I could say, in the directions, I could say like something like hint sine of 40 degrees equals 0.642. Excuse me, that's a very bad start to a 2. 2 and 8. So, and then from here, it's just a matter of multiplication. And doing 15 times 0.6428 is not an unreasonable multiplication to expect you to do. So why don't you do that multiplication? So we have h equals 15 times 0.6428. All right, and we'll talk about the answer on the back end. All right, hopefully you paused the video and got the same as me. I got about 9.6 is the height of your triangle. Now, since side A, right, A equals 12, your H equals 9.6. Since A is greater than H, but A is less than B, there are two solutions. So if A is greater than H, but A is less than B, two solutions. All right. So now we are being tasked with finding them both. All right. So the first solution, and let's do this. So the first solution is where angle B is acute. All right, the two solutions are going to differ in the sense that either angle B is going to be acute or angle B will be obtuse. In this case, we have two possibilities, so we're going to have to find them both. All right, so let's redraw our triangle, but let's draw it with angle B being acute. So there's A, there's C, there's B, here's 15, here's 12. All right, and I believe angle A was 40, right? So let's put in the 40 just for kicks. And then we're going to use the law of sines. So I have 12 over the sine of 40 degrees equals 15 over the sine of angle B. All right, now again, it's cross multiply and divide, so the sine of B equals 15 sine 40 degrees over 12. And once again, this is one where you would have to use a calculator to solve. So why don't you guys go ahead and solve for angle B. You guys should be experts by now, and I'll give you my answer on the back end. Okay, hopefully you paused the video and took a moment to solve for angle B. All right, so angle B is the arcsine of 15 sine 40 over 12, which is then going to equal about 53.5 degrees. Now, angle C is going to be a lot easier. All right, and again, angle B, one being acute. Angle C is going to be a lot easier because we have 180 degrees minus 40 degrees minus 53.5 degrees. Whatever's left is going to be angle C. And I got, you certainly can check my work, 86.5 degrees. So now we're going to look for side C. So I have C over the sine of 86.5 degrees equals 12 over sine 40 degrees. And why don't we cross multiply and divide? Again, you're going to have to use a calculator on this one. 86.5 is not a unit circle measurement. 40 is not a unit circle measurement. But writing this down is important to teachers. So write down 12 sine 86.5 divided by the sine of 40. All right, this is kind of, in a sense, showing your work. Now, you're going to have to put this in a calculator to get a number out. But what if you put it in and you weren't in degree mode? You would get a wrong number out. But showing your work is really beneficial so we know that you know what you're doing. I got 18.6 for side C. All right, so there's angle B, there's angle C, and there's side C. That's what we needed to solve this particular triangle. Now I want to go and see what the other possibility is going to be. And the other possibility is going to be angle B is obtuse. All right, so I'm going to redraw my triangle. But I'm going to try to draw it in such a way that angle B is obtuse. So there's 40, there's 12, there's 15. All right, so my first angle B equaled 53.5 degrees. So my second angle B is going to be supplementary to that. Now I'm going to take you very quickly why that is true. All right. So I'm going to quickly draw out okay, so here is my 30-degree angle and there is my 150, right? But notice the y values are exactly the same at 30 and 150. All right, so, and 30 plus 150 gives you 180. They are supplementary to each other. Well, that's going to be true of all angles contained in quadrant 1 and quadrant 2. So for example, if I had 20, the angle that would have the same exact sine as 20 degrees would be 160 degrees. The angle that would have the exact same sine as 45 degrees, right, would be 135 degrees. So, right, if they have the same y values, they have the same sine. So the way I can find my second angle B, I could say 180 minus 53.5. And obviously, you're always welcome to check my work. I got 126.5 degrees. So there's my second angle B. Right? And now for angle C, I could say 180 minus 40. And I keep putting the degrees for a reason. Because again, your calculator is radian and degree mode. It's important that you remember that we're working with degrees. Minus 126.5 degrees. And I got 13.5 degrees. So we got our two angles. Now the last thing we need to do is find side C. Side C is going to be different, obviously, if our angles are different. So I got C over sine of 13.5 equals 12 over sine 40. So why don't you guys pause the video, get me side C, round to the tenths, and we'll talk about the answer on the back end. All right. Hopefully you paused the video. I got C equals 4.4. And we'll say that the units are centimeters because that's what we said in the beginning. All right, one last example on this topic, and then we have one more topic to go. Be relatively quick. This could arise. So I could say, right, here's my example. A equals 2, C equals 1, and angle C equals 50 degrees, right? So I'm just going to sketch out a triangle. I'm going to put 50 here. I'm going to put 1 across from it, right? And you could pick your side A. So there's side A. It doesn't really matter too much. But what does matter is the law of sines. So we want to find angle A first. Because if we find angle A, angle C is just addition. So I have the sine of 50 degrees over 1 equals the sine of A over 2. All right, so if we cross multiply and divide, I got 2 sine 50 divided by 1 equals sine A. So why don't you do this, and we'll talk about the answer in just a second. Give me what sine A equals. All right, well, hopefully you did this out. I got the sine of A equals 1.53. Now you might say, okay, well, what is angle A? Well, if you were to do sine to the negative 1 of 1.53 in your calculator, you would get some sort of an error. Now, the reason you would get an error is because, remember, on our unit circle, sine is as great as 1 and as low as negative 1. Right? But we have a sine of A of 1.53. That can't happen. So this answer, right, is impossible. Therefore, our conclusion is this is not a triangle. Right? If that answer is impossible, then these measurements don't hold up to be a triangle. Remember, we just did that freehand. We didn't actually, measure it out. So that's something to keep out on the lookout for. All right, now the last topic we want to do is area of a triangle. Now we all know that area of a triangle equals 1/2 base times height. But if we have an oblique triangle, like ours, we don't necessarily know the height off the top of our head. All right, but as long as we have two sides and an included angle, we could use an alternate formula to get the area. And that alternate formula is 1/2, AB, that's sides, and then sine C to get our area. All right, let's do 2 quick just to get a feel for using this new formula. So if I say if angle A equals 150 degrees, side B equals 8 centimeters, and side C equals 10 centimeters, find the area of the triangle. ABC. All right, so if I drew out a picture real quick, right, there's my 150, there's my 8, there's my 10, because this is side A over here. Now, we're not looking for sides now, but I got to make sure that I have two sides and an included angle. And look, I do have just that. I have two sides, included angle meaning the angle in the middle. So let's use our formula. Area equals 1/2 times 8 times 10 times the sine of 150. All right, So now this particular problem, you don't need a calculator. All right. Sine of 150 is on your unit circle. 8 times 10 is a fairly basic multiplication. So do me a favor, guys. Let's multiply it out, and we'll talk about the answer on the back end. All right. So area equals 1/2 times 8 is 4 times 10 times a half. Right? The sine of 150 is a half. And this total is 20 centimeters squared. Remember, we're getting area, so our units are going to be squared. All right, now that's a very straightforward problem where it's just, here's the information, find the area. I have 2 more problems to do. They're a little less straightforward, but it's the same information. We're just asking for different things. So let's try it out. Let's see. So I have my example is an area of an isosceles triangle is 49 inches squared, and the measure of the 2 sides is 14 inches each. Find the measure of the angle between the 2 sides. So here is my triangle. Remember, the 2 sides are 14. Okay. And I'll call this angle A, right? My included angle, we don't know, because the question that we're asking is, our included angle equals how much? So let's start with our area formula. So I have 1/2. And now if that's angle A, these have got to be B and C. So again, it's our side times the sine of our angle. All right, side times 1/2, side times the sine of our angle. So area equals 1/2, 14 times 14 times the sine of A. All right, so if we do the multiplication, I got 14 times 14 times a half. So our area, which is 49, equals 98. And again, certainly welcome to check my work. That should equal 98. Sine of A. So the sine of A equals 1/2. And where on your unit circle does the sine of A equal 1/2? Angle A equals, most definitely, 30 degrees. So again, we're using the same formula. I'm providing slightly different information in order to get, at one of the other letters in our formula. All right, so here is one more problem. Again, we're going to just change up the information, but we're going to use the same formula yet again. I'm going to read you the problem. If the area of a triangle is 15 inches squared, so the area equals 50 inches squared, if side A equals 9 inches and angle C equals 72 degrees, find to the nearest tenth the measurement of side B. All right, so all I did was write down the given information and what we're looking for. Now I have a hint. My hint is sine of 72 degrees equals 0.9511. All right, so we got to find side B. So again, I'm going to use my area formula equals 1/2 AB sine of angle C, right? And that's because I have side A, I have angle C, so this would be the appropriate way to write the formula. All right, so my area is 50, 1/2 times 9 times B. And the sine of C is the sine of 72. So I'm going to fill in the sine of 72. So I have 50 equals 9/2 B times 0.9511. All right, well, 9/2 is 4.5. So I'm just going to write 4.5. All right. So why don't you do me the favor of finishing this up for me? Again, it's just multiplying those two together, dividing by 50, or dividing that number by, 50 by that number. And let's see what we get. Round to the tenths, right? Find to the nearest tenth is what the problem said. All right, hopefully you pause the video. If not, pause it now. But I got B equals 11.68 inches. But I want to round to the nearest tenth, so I would say 11.7 inches. All right, guys, a lot was covered in this, and I know this is part 2. So thank you for listening. There's a lot more practice to go. I look forward to seeing you guys soon.